first let's start with the standard model of particle physics. Let's take an object. Let's take this block, for example.
Mm-hmm.
What is it made of? If you break it down into smaller and smaller pieces, from molecules to atoms to electrons to quarks, at each stage, as you break it down to smaller pieces, what do you see?
Right. So it's made out of some form of plastic, which is a polymer. It's a molecule that's a long chain of hydrocarbons mostly.
Mm-hmm.
And if you look down into that, you could look with a powerful enough microscope and you would see, I suppose, I don't know exactly how they're arranged, maybe randomly, but you'd see a sort of spaghetti swirl of these polymers. You zoom in on those and you'll see the structure of a hydrocarbon, chains of carbons with hydrogens attached. You zoom in on those atoms and you'll see that there's a nucleus, which in the case of hydrogen is particularly elemental. But there's a nucleus which contains protons and maybe neutrons, and with a probability cloud of electrons, what people used to describe as electrons orbiting around the nucleus like a planet around the sun. We know from quantum mechanics, despite the fact that that is still taught to children in schools to this day, but what we know now is that
it's all a lie.
Yeah, it was all a lie. It's not like a planet orbiting the sun. You can convince yourself of that immediately just from the fact that if it was, the electron would radiate electromagnetic radiation and fall into the nucleus in a tiny fraction of a second.
Yeah.
So it cannot be that, and it's not. It's a quantum mechanical wave function where the electron it's in a state where it has a probability of being somewhere near the nucleus.
Mm-hmm.
But not in any particular orbit. So now if you want to go further, as far as we know, electrons are fundamental particles. We've never seen any substructure in them. But protons and neutrons, those definitely have a substructure. So if you zoom in now on this nucleus and down onto one of those baryons, onto the proton or the neutron, you'll see that it's composed of 3 quarks.
Mm-hmm.
Those are smaller subatomic particles with fractional charges. And so the theory of quarks dates back to the 60s, and it was confirmed experimentally more recently than that, but by particle accelerators that smash protons together, for instance. So we're quite sure that there are quarks inside protons and neutrons. If you go inside quarks, again, it's like an electron. We don't know that there's any substructure to those. There might be, and I think most physicists would tell you there has to be. And I tend to agree, but we don't know for sure what it is. So that's as far as we've gotten in terms of, let's say, theories that we're quite confident of and that have been experimentally well tested. And beyond that, it's more speculative.